Yesterday we introduced the concept of redox, and today we will be examining how we write redox half equations. The example that we spoke about yesterday was oxidizing a solution of iron 2 ions with a strong oxidizing agent, potassium permanganate. I have here two tubes, both filled with iron 2 ions. We'll use this one on my left as the control. When iron 2 ions get oxidized, they lose electrons to form iron 3 ions. The oxidizing agent is potassium permanganate, which is a purple color. When I add the purple permanganate solution into the iron 2, you can see that the purple color disappears on impact with the Fe2. If I was to simply have put the permanganate into water, the purple colour would have diffused throughout the test tube, and eventually we would have a purple solution throughout the test tube. But that's not the case here. The purple colour disappears on impact because there's a chemical reaction occurring between the Fe2 and the permanganate ion, MnO4-. If we were to simply time-lapse this, you can see that the permanganate continues to disappear, but the solution, rather than being a pale green colour, is starting to slowly turn to a straw yellow. Indicating a chemical reaction has occurred. The permanganate, being the oxidizing agent, is itself reduced in this chemical reaction. The reduced form of permanganate is the manganese ion, Mn2+, which is colourless. So any change in colour that we see is due to the Fe3 ions being produced, which are straw yellow in colour. Eventually, if I add too much permanganate, there'll be no Fe2 ions for it to react with, and so the solution then will take on a permanent colour of purple, indicating an excess of permanganate. So we can now see that you've got a pale yellow on my left, a pale green on my left, which was the original Fe2 ions, and a pale straw colour on my right, which is the Fe3+ ions.